Yes. We start with this proposition. This is some state terms. Phi of R is the purification. So it's an element of natural tensivity.
That is an element of the Hilbert space, right? I mean, that's given by Hilbert spaces.
So we'll just take it to be this, and whenever we want to write the element of the Hilbert space, we write it as like as this. So whenever we want to talk about the vector, we write it like this. Then for all extensions, omega r prime of rho v. This means that case of r prime omega r prime is rho v. There exists a quantum channel n equal from r to r prime such that one identity tensor n of the purification is the honesty. So this is the proposition. It just says that if I take a state and its purification and any other extension of rho A, then there will be some channel from R to R prime such that the purification takes you to the other extension. So I'll prove this. So consider purification of this state itself. So let I then since this is a extension of rho A, we have the following. If I take the trace R prime prime R prime, so this just means H R prime R double prime H R prime. Like I'm taking tensor like trace with respect to this Hilbert space, like of this state. You will get trace R prime of omega R prime is equal to 0. So this just says that this is also a purification of rho A. So then by isometric equivalence of purification, we have the following. There exists B R prime R double prime of H R. I think so. Like we have a unit in such that it takes some isometric, yeah. It takes the corresponding, so this state, it takes this state to the state corresponding to that purification. So I'll just write it down. V of pi is pi R11. So this just translates to saying that if I conjugate this state with P, then I'll get this other purification. So then we can define using this V channel. So I'll it's not moving.
You have already. Just no, down, not the bottom. This one.
Oh, okay. Oh, then we just see that if I take R right, of take RG that's this, then of this gives I'll get this is what we want. So we have this, we have the first proposition. This I'll just recall the string representation. If I have a channel EPG, then this can be given as these index, these stuff, that these cumulative so now I'll talk about degradable and anti-degradable channels. So
Complementary channel also 85 volts.
okay. So if I have a channel, then like A to B, then complementary channel of N is so is given by case C of stiffness is the of the fixed state. So if I take a trace with respect to E, then I'll get the original channel. If I take the partial trace with respect to B, then I'll get the
It's not unique, but unique applies. So
yes, it's unique. Yes. So I If I have a channel from A to B, I'll just so I have L of H, A of H, P of H. I'll just write them as T, B, and um, if like I have a channel from A to B, I'll call its complementary channel and complement. Uh, this channel is called degradable if there is a channel D to D or D such that this couples. And on the other hand, N is called anti-degradable if uh, this uh, uh, we have the same situation, but there will be a map from A to B. Uh, such that this couples. Uh, proposition.
What is on this map exists?
Uh,
That is definition.
that is the
That is
definition.
degradable if it exists. If it's anti-degradable, so it's not guaranteed.
So proposition. N A to B is anti-degradable. Oh, it's choice thing. Which I denote by phi superscript and subscript N B is equals to.
We can define what is filling AB. We haven't defined as the scale. We defined as the positive relationship. This is, this is a new notation. This is phi and AB is 1 by square root of
Yeah.
times whatever the scale is. We will define.
Okay, so 5 and B. So we have uh, so 5 and if I let's see identity that's well,
That's not P, that should be P. That should be that's a projection P or something.
so it is the maximal entitled state. Like the so
No, you are using the same symbol, no? P for that and this. We use some P, capital P.
Yes.
Maybe better or gamma gamma.
Yeah.
This P is, it will be confusing with that.
Yeah. Like I'll just write down what.
No, but that and just notationally it is confusing with that field. You have a phi,
Yeah.
which is you define it to be the choice state of that. This is not a choice state of anything. So you are using a phi for something which is not a choice state of anything. Right?
Yeah.
It's not a choice state. So you use phi means that is confusing.
Okay.
You use some phi or something like we use P. Yeah.
I'll just
Yeah, that is right.
okay. So like where so this is like the so
So there is no fee here, right? This has nothing to do with any complication.
yes. So okay, so this is like so it's the choice state of NAB is too extendable. Like if and only if N is anti-degradable. So what it means for phi the choice state to be too extendable is that there exists a state
But how does that mean?
uh, means
Means.
so there exists a state sigma e prime and which we are taking B and B prime, we are identifying B and B prime. So there exists a state in this such that um, it's an extension of um, like of the choice state. Yeah. So I'll have so the trace with respect to B or B prime of this extended state is
Yes,
given by
you are taking the trace partials.
So, so I'll fix some notation. So I'll call V to be the span spring, like unitary isometry that we get from N. So
Which way you are going?
I'll define certain things and then I will start. There exist V. I will have an isometry by Steins by the Steins scheme. So is that if I denote script V as the conjugation with V, then the channel N is just given by composition of the trace with the this conjugation, the isometric channel. Uh, so and also we'll have that N complement the complement channel is this trace V properties with respect of the unitary channel. So, like any, like it just says that any channel is like you have a unitary channel and you restrict it by a partial case. So, so the, it's like, so let omega EVE be the choice state of this unitary channel. So that means that it is, I think, so the same thing, but like with unitary channel we are doing. Um,
It's isometric.
hmm?
It's isometric, not unitary.
Sorry, isometric channel, yes. So it is clear that this will be a pure state in this case. So
Why is it? From here it's not clear.
yeah, I'll show that. So so this so this can be written as ID intensity. So okay, start like you can just uh you can just be this.
What is Q? One times. Oh,
Yeah. So, and this is, since this is uh just this meeting, this can be written, this itself is a pure state. So I'll just call it the uh,
This pure state is not from clear from the, you have to write it as gamma, gamma. Gamma is the maximal entangled state. Then it is the pure state corresponding to it. That is
Yeah,
correct.
yeah.
So,
so so this is
and that should be
Yeah.
gamma. That gamma.
Yeah.
Gamma is 1 by square root of the summation over R.
Yeah.
EI times EI times I.
Yeah. So I'll just write it here. Like it's and then that is the journey. So this is itself. Yeah. Yeah. And now this itself, this can be written as
Now.
Hmm?
No, which is PA. You are applying to PA, right? Oh,
Yeah. So okay, this will be like one, like the identity in the
so it should be. Is it one tensor gamma gamma or both gamma gamma?
uh,
Gamma is in A or A correct? Not. It should be one tensor.
yeah.
It will be one tensor.
Oh, okay. Like one tensor gamma.
No. One tensor gamma will not be true. But why do you want to tensor with another identity? What is it?
I'm just applying this to this matrix.
PA. But you are applying to PA, right? Not to.
Yeah.
And that's your person. Yeah, that's okay. This is gamma gamma only.
Okay.
Yeah.
Yes.
Sorry. This is okay. This is how it is defined.
Yeah. So now then, like we can just take the set side basically. So one that's so if I just write it like take out this part, we'll just get this like so this itself is a uh, like it's a pure state because it's like we have written it in a pure form. So further, you notice that the choice state is an extension of the choice state of both the choice state corresponding to n and n complement. So the choice state, this is the choice state of the unitary channel. Sorry, isometry channel. This is an extension of the choice states of each of the each of the choice state corresponding to n and the n complement.
You take the corresponding partial phrase, you get that.
Yes, yes. So that is what I'll show right now. So in so you got uh, So, like I just wrote out the definition, like expanded it. This is like the choice state of uh, the isometric channel, and we are taking trace with respect to E. But since the first call, the like this is identity, I would like to separate out the identity, the case itself, so that I can write it as identity. And so the case of E, my composed with E, this itself we know that this is equal. This is the unit to I mean, it's like the channel equals to like so then this that means that this entire thing is just the choice state of like n. So similarly, if I take trace with respect to b of ABD, I would get n complement b. Like out here it'll just be replaced by b, and that trace and that will become the n complement. So we'll have this. So now we prove the forward direction. Like now we set up the rotation. Like so, assume n is anti-degradable. That means that there exists a from here, such that when we is so then like if I take identity tensor, it's everywhere. So that will correspond to any understand you composite and complement. And now I apply this operators on super operators on the data example of both sides. Uh, then you'll get that the left hand side will be the choice state um, um, of n. So that'll be this is I instead of the choice state complementary choice. So like we just used that like the channel going to its uh, uh, choice state is functory. So um, like,
So what about the tools? W external.
uh, yeah, I'll come. Yeah. So yeah, so we define this. So we anyways had the choice state corresponding to uh, the isometric channel. So we would like that is some state in ABE. So what this A does is that it takes states from like A to B. So like like we since B and B prime are identified, we just abuse notation and we just say that like uh, uh, like if A is from E to so I just consider the corresponding A E to B prime. So so we define this. So we get the uh, the state that we want in the theorem. We show that this is the extension of the choice state. So yeah. Speed of this case. So now I will show that this is equal to uh, P A inside piece of so I will show that I can take the trace to the other side while eliminating B from this expression, this part. So like for this, I just take the state. I just write it as AI tensor, AI tensor CN. Uh, because we would want to apply this part on this state. So uh, I'll paste B. So now we have it in the form of some. So this is an element of uh, L of HA. HA. This is an element of L of HB, and this C is an element of L of HC. So this is an element of L of HB. So
No, you go.
yeah. So while taking trace, I have to take trace with respect to B. So I take trace of this, and this will just be a trace of B times AI answer AC. So this is equal to when you look at tensor B of solution or basically yeah, tensor C. And this is nothing but it's B of um, tensor C. So uh, like we like just like by calculation, I saw that I can take the trace of BI. So I have this here. Then now I just take like it's easy to see that identity 8 and say applied on this, you'll get this right this okay. So now this is just trace of B applied on this vector. And this vector is the original vector that we structured.
We're trying to do. We're trying to prove this.
I'm trying to prove uh,
The extended version.
like I'm just trying to prove this step. Like I can take the trace to the other side of this game. So that's the only like point of the. Oh. So we have proved this side first question, like the first. Now we know that like we just saw that like if I take trace D of this of we'll get the complementary channel. So we'll have here the joystick corresponding to the complementary channel. and this is so like we just saw that if I like take identity A length and A applied on the complementary choice state, we'll get the original choice state. So this will be the original choice state. So we show that trace of B with respect to of this state will get the choice state, the original choice state. So we showed that. So and similarly, we'll get trace B prime sigma A B prime to be the same thing. But there'll be prime. So like B and B are identified. So it doesn't matter. So so we show that it is too extendable. So now we show the other direction. Okay. So assume that exists a state such that she is just is so we have such a state. We want to show that is a degradable channel. So we want to map from A to B prime. So, uh,
E to B.
E to B prime. That's correct. Yeah.
So there again with C.
No, you check it.
It was right.
Huh?
It was right.
Yeah.
Keep it together.
So, since we know that uh, omega EVE is a purification of this choice state. Of this choice state. And also sigma E B prime is an extension of the same choice state. So then by the earlier proposition, there exists a channel. There exists a so this applied also. There was here. So this is how we get uh, the map.
You using your lemma proposition.
Yes. So from now we just have to show that we just take trace on both sides of this. So we'll get trace of so we just take trace both sides. Out here in the this side we have trace B sigma E prime. And then this will be equal to just the first state. On the other hand, out here, if I take trace, like by the earlier argument, we can take the trace B inside, such that this will be equal to like B tensor E prime. And out here we have trace omega AB. Um, so, and this is our complementary channel, uh, like the choice state corresponding to our complementary channel. So we show that ID tensor P of the complementary channel is our uh, choice state of the channel. So now by like the injectivity of the choice, like for every channel, there's a unique choice state. So like the choice, uh, like that will just say that, okay, I'll just do more another calculation. So this is, I think that's eventually. Let's see.
That is indeed the child state, and so that the association of the child state is one.
Yes, yes, yes. That's exactly how I conclude this. So, yeah, like I'll just write this down. Um, so, and this is just equal, like, uh, uh, out here we'll have ITDA and search this, and out here we'll just have yeah. So like this, yeah. So we'll have this. So from this we can conclude that the choice state of this and the like the since the association of choice state to the channel is 1 1, we have that uh, E compose with N complement is N. So that proves. The question of like double length, so assumption.